All right, this will be a review video for the polynomials quiz coming up. Just jump right into it. Classifying polynomials by degree and number of terms. You just got to memorize these. They're not too hard. You look at the biggest exponent. This one is clearly linear because the biggest exponent is a 1. I could fill a little 1 in there without changing it. It's got 2 terms, so I'm going to call that a binomial. Over here, we've got a 4. 4, don't get confused, that's not a quadratic, it is quartic. Different root word for 4, quartic, one term, monomial. Okay, end behavior. All right, when we're talking about end behavior, we're talking about what happens at the extreme ends of this graph. It might be going up and down in the middle, but eventually it's going to pick a side and go either up forever or down forever. So what I look at is that my first coefficient here is positive. That means that this thing is going to go up as we go to the right towards the positive numbers. It will also be going up. All right, and then I look at my biggest exponent. This is odd. And so I know that it's going to have opposite end behavior on the other side. All right, how we say this with words is that this rises to the right and falls to the left. One other way we could say is we just call it going left to right. We go, this is down up end behavior, down dash up. So a lot of different ways to say it. Over here, this one is going to be down down, or falls falls, or you could draw a little picture, just be able to pick the right answer for that. All right, find all the zeros. So these are already in factored form, which is really nice because when they're in factored form, we can use something called the zero product property. And that states that if I set this equal to 0 here, find all the zeros, then to make this equation true, I only need to make one of the factors equal to 0. Because when I'm multiplying, if one of my things is 0, then the whole thing is 0, and this equation would be true. So I've got 0 equals 3x plus 5, and 0 equals x plus 2. Subtract 5, subtract 5. Negative 5 equals 3x. And hopefully we can all see why x equals negative 5 over 3 there. And for this one over here, x is going to equal negative 2. All right. Moving on, write a polynomial function in standard form. We'll talk about what standard form means that has the given zeros. So it's really easy to write it in factored form. The hard part is going to be converting it to standard form. Factored form, we just can use that zero product property in reverse, and we'll just say y equals x plus 1. This way, it will definitely have a 0 at negative 1, because that'll make this linear factor here equal to 0. There should be an x for that 0 at 0, x plus 2, x plus 4. But now to get into standard form, I need to actually do the steps of distributing this, getting all my like terms together, and so on. So I'll distribute this x here. I can save a little bit of time by doing the first two factors, combining those, at the same time combining the third and fourth factors, and then I can just combine everything. Parentheses are going to be key here to help keep track of what still needs to be distributed. So there, I'm going to distribute this, FOIL this. I get y equals x squared plus x. Keep that in a set of parentheses. And right here, this is going to be x squared plus 4x plus 2x makes a 6x. And my last term's giving me a plus 8. And now to do this distribution, I make sure, draw all my arrows, and I make sure that every term in the left gets multiplied to every term in the right expression. So hopefully these arrows here will make it clear what I'm multiplying to get this next expression. X equals x to the fourth plus 6x to the third plus 8x squared. All right, so I multiplied my first term to all three of these. Now I switch to my second term. Plus x to the third plus 6x squared plus 8x. All right, and final answer. Here, y equals x to the fourth plus 7x to the third plus 14x squared plus 8x. Well, I didn't miss any terms there. Let's go look at number 7 real quick in the answer key. 7, 14, 8. Is that what we got? 7, 14, 8. Yep. Okay. So for this one here, I'll just get it set up for you. If I see -1 mult 2, that means when I'm writing this out, I need to have a factor of -1, which would mean x plus 1 is a factor. I need to have that one twice. That's what the mult 2 means. All right. And then for the rest of it, we got x plus 4, x minus 3, x plus 3. That's going to take a little while to distribute. But it's good practice. Just staying organized, making sure you multiply everything to everything. Okay, moving on. Factor each and find all roots. So a lot of different types of factoring here. This first one is simple factoring. We know that because it's got an a value of 1. And I can think of two numbers that multiply to be 2 and add to be 3. Those numbers are 2 and 1. And now we've got our answers: x equals -2, x equals -1. And we're done. Let's see, simple factoring. This one's going to be 4 and 5. -4, -5. This one's going to be -3, +1 for our factors. You got to flip those. 13. Now I see 4 terms. Anytime you see 4 terms, 4 terms equals try factoring by grouping. All right, it might not work, but it's pretty quick, and when it does work, we get our answer really quickly. So I'm going to create my groups like this. I'm going to pull out the greatest common factor of that first group, which is going to be an x to the third, leaving behind an x minus 2. I'm going to pull out a negative x from, yep, negative x will work from the second group. We get an x minus 2. That way, if I distributed that negative x to the -2, I would get a positive 2x. All right, it factoring by grouping did work because I got that same factor. I was able to pull that out of both the first 2 terms and the last 2 terms. Now I rewrite it as x to the third minus x and x minus 2 equals 0. I've already got 1, 0, x equals 2. 0 product property again. Let's set this other one equal to 0. I've got x cubed minus x equals 0. That's coming from this right here. Why don't I pull an x out of that? Greatest common factor. X and x squared minus 1 equals 0. That x there is going to give us a 0 at 0. So 2 roots. And now zero product property again. Switch colors. X squared minus 1 equals 0. I'll add 1 to both sides. X squared equals 1. I'll take the square root. Excuse me. And square root of 1 is a positive 1. And it's a negative 1. Both of those squared give us a positive 1. So we need all 4 values. All right. And so that's all for number 13. Let me cross out 14. 14 looks like another factoring by grouping. Even easier one, honestly, than 13. This one, pretty sure can be factored by grouping. Let's just see. Yep. What we're pulling out is a 1 there, just to kind of complete the motions. X squared plus 1, x plus 2. This one here is going to give me some imaginary roots for number 15. That's going to give me x equals plus or minus I. So I'm going to take the square root of negative 1. And then this here gives me x equals negative 2. All right. And that one looks like factoring by grouping. You get an x plus 4, yep. All right. So all of those could be factored by grouping. What is the y-intercept of the following? Negative 4. It's always our constant term. There we go. One way we can prove that is we could plug 0, x is equal to 0 at the y-intercept. That makes all of these terms cancel out, and that's why we're left with the negative 4. Okay. Which line represents a double 0 and which represents a triple 0? Double. Triple. You could think that this is crossing the x-axis and going back at the same point on the x-axis. This one's crossing, going back, and then going back again. 3 crosses all at the exact same point on the x-axis. So what's happening here, let me zoom in, use my infinitely fine microscope to see that it's going like this, except for all 3 of those points are the same value. All 3 crossings are the same value. So 3 crossings at same x value. So kind of weird to think about. They can be crossing 3 times at the same point, but it makes our fundamental theorem of algebra work if we call that a triple 0. Also, that's called a point of inflection. Maybe there'll be an extra credit question about that. Inflection, okay. State the maximum number of turns. This one is going to be 3. This one's going to be 2. It's always 1 less than this number here. So 4 minus 1 equals 3. 3 minus 1 equals 2. Simplify. We got some operations with imaginary numbers here. When we're adding, it's just like combining like terms. Subtracting, don't forget to distribute that negative so you avoid making mistakes there. Let's do 24. 2 plus I squared is going to be expanded to 2 plus I times 2 plus I. When I FOIL that, I'm going to get a 4 plus 2I plus 2I plus I squared. That's going to give me a 4 plus 4I. And then I squared, anytime we get an I squared, we use this definition to simplify it. I squared equals negative 1. And so I'm going to do a minus 1 there. Combine my like terms. I want the real part in front, the imaginary part at the end. 3 plus 4I. Final answer. Now you don't have to write your I's like me, but please do something to make it look like a letter and not the number 1. I always give it a kind of a funny looking tail. You got to make them look different somehow. All right, so if there's ever a monomial in the bottom of a fraction that has an I, you just multiply by I over I. That's going to work for both 25 and 26. Here I'll simplify 26 since it looks like the harder one. This here, I distribute that I get a negative 10I plus 4I squared all over negative 2I squared. Those I squareds need to become negative 1s, negative 10I minus 4. Hopefully we're okay with me just exchanging the I squared for negative 1 and then multiplying it to the 4 to get a negative 4, and then this becomes a positive 2. All right, rearrange, and also I'm going to divide the top and the bottom by 2. Well, actually, I'm just going to distribute that division. I'll just get negative 2 minus 5I. All right, so I distributed the division there. Okay, a couple more steps in like 27 and 28, but the process doesn't really change. 29 and 30, however, we do need to bring in another concept. This is the concept of the complex conjugate. All right, so I'm going to, for number 29, I'm going to multiply by negative 7 plus 2I over negative 7 plus 2I. Now right there, it's called the complex conjugate. Very easy to find though. You just have to flip the sign in the middle of the imaginary number at the bottom. All right, add some parentheses to help organize this distribution here. And we're going to get negative 21 plus 6I on the top. And on the bottom, we're going to have some things cancel, but I'll write it out. 49 outside gives us a minus 14I. Inside gives us a positive 14I. Those will cancel. And our last terms give us a negative 4I squared. All right, let's cancel these and rewrite it. Down below here, negative 21 plus 6I all over 49. That I squared becomes a negative 1, so this is going to be 49 plus 4. And this whole thing, negative 21 plus 6I, all divided by 53. Yeah, none of those share any common factors, so I think we're done. Let's just look at 29. Maybe they simplified it differently in the answer key here. Negative 21 plus 6I over 53. That's what we got. All right. So we'll need the complex conjugate for all of these. 31, 32, you're going to have to FOIL the top and the bottom, but you should get to an answer that looks kind of like this still. Okay. Find all zeros. Let's do 34. 34 looks kind of maybe on the more tricky side. To find zeros, we're going to set this equal to 0, then the zero product property to break it out into x plus 1 equals 0, and x squared minus x plus 1 equals 0. Minus 1. We get x equals negative 1. That one was easy. But what are we going to do about this one over here? Let's see, is it factorable? Two numbers that multiply to be 1 but add to be negative 1. Those numbers do not exist. Or at least they're not integers. So what I'm going to do is quadratic formula, but this one's going to be really easy to do with quadratic formula. I'll just kind of do it out loud here because I'm going to simplify a lot as I plug in the values. So negative b, that's going to become a positive 1, plus or minus the square root b squared is going to become a positive 1 again, because negative 1 squared is positive 1. Minus 4ac, well, a and c are both 1, so it's just minus 4. All over 2a, well, a is 1, so this is all over 2. How do I simplify this? So if you have 1 plus or minus the square root of negative 3 all over 2, which equals, and this is going to be our final answer here, 1 plus or minus the square root of 3i all over 2. So that negative jumps out and becomes an I. Everything else can stay the same. We can't really simplify this too much more other than just distributing that division, but I'm going to leave it like that. Let's see, long division of polynomials. Okay, so am I allowed to do synthetic division here? Because if I am, I really want to, because long division is just a lot of repetition. Let's see, this is linear. It is a binomial, and it's got a leading coefficient of 1. So it checks all 3 boxes to be able to do this by synthetic division. So let's do it by synthetic division. 1, 1, negative 52, 32. All right, what value makes this equal to 0? Another way to ask is, what is the root given by this? It's negative 8. And now we add, multiply by that negative 8. Add, we get negative 7, multiply by that negative 8. We get a positive 56. Add the column, we get a 4. This gives us a negative 32. Our remainder is 0. I put a box around our remainder. And now these numbers here are the coefficients of the resulting quadratic, p squared minus 7p plus 4. That is our answer. All right, so we divide that whole thing by that, we get this answer. All right, 1 0 has been given. Use synthetic division to simplify the polynomial and then find the remaining zeros. All right, it kind of just tells you what to do there, which is nice. 3, 13, 13, 3, and it gives you the 0. We do not have to flip this sign here. All right, this is the 0. This is the root, so you just put a negative 3 over here. All right, let's do our synthetic division now. We drop this down, I get a 3, multiply, that's a negative 9, add, 4, multiply, negative 12, add, positive 1, multiply, negative 3, remainder of 0. This gives us the coefficients 3x squared plus 4x plus 1 equals 0. Now, hopefully we remember our unit on quadratics, because to factor this, I need to do factoring by grouping. It's a very easy case of that, but we still not have to do it. So 3 times 1 is 3. I need to split 3 into factors that add up to 4. Those factors are going to be a 3 and a 1. All right, now I write this out as 3x squared plus 3x plus 1x plus 1 equals 0. Now it's a polynomial of 4 terms. Let's try factoring by grouping. 3x, x plus 1, plus 1, x plus 1 equals 0. Let's see, where do I want to go with this? I'll just keep moving in this direction. Now we get together our groups. We've got a 3x plus 1 times x plus 1 equals 0. Set these individually equal to 0. 3x plus 1 equals 0. X plus 1 equals 0. And subtract 1, subtract 1. 3x equals negative 1. X equals negative 1 third. And over here, x equals negative 1. All right. So a little bit of factoring by grouping in there. Hopefully we remember that. Just has that added step of splitting our middle term, and then everything else is the same. Let me just kind of clean this up. Like a -1. Let's see, 37. We got -1/3 and -1. Let's see what it says. Yep, and then the given root was -3. All right, let's do another one of these. Number 40 looks like it could be kind of tricky. Probably another one that'll evolve into factored by grouping. So here, let me try writing smaller this time too. 4, 5, -4, -11, -2. Our known root is 2, 5, 10, 6, 12, 1, 2, 0. This gives us the quadratic 5x squared plus 6x plus 1. All right, set that equal to 0. This is going to be factoring by grouping. I'm going to split this into a 5x squared plus 5x plus x plus 1 equals 0. Do the polynomial greatest common factor of a 5x. And this one's just a 1. Now I've got 5x plus 1 times x plus 1 equals 0. This gives me the roots -1/5 and -1. All right. 42 is an interesting one because now we've been given 2 zeros. But all that means, so I've got this 0, -2, I've got it 2 times, means I can do my synthetic division twice with that 0, and then I can just finish out the synthetic division. So here we go, 2, 7, 3, -8, -4. The known root is -2. Drop a 2, multiply, -4, add 3, -6, -3, 6, -2, 4, 0. And now let's just, I'll rewrite it. But so that was one of our 2's. Let's do synthetic division again with the other 2, since we know 2 of the roots are a -2. So -2, we get 2, -4, -1, 2, -1, +2, 0. And now we're down to just a quadratic. That quadratic is 2x squared minus x minus 1 equals 0. Can we get this one with factoring by grouping? Factors of -2 that add to be -1, -2 and 1. So 2x squared minus 2x plus x minus 1 equals 0. Pull out a 2x, leaving behind an x minus 1. This one's just a 1. So then we get 2x plus 1, x minus 1 equals 0, x equals -1/2, x equals 1, 1/2, -1/2 and 1. Let's see. -1/2 and 1. Good. All right. last one. We have to do long division for the last one because we've got a leading coefficient of 3. Let's do this now. It's our last problem. Stick with me a little longer here. To do the long division, we got to copy down that the whole polynomial, put it underneath a long division symbol, and then I'll kind of talk you through how we do the long division. It's really not too bad. It's basically like doing synthetic division, but you just got to write a bunch more r's and keep track of your positives and negatives a lot more. Okay, on the outside of our long division symbol goes that 3r minus 1. Okay, we're set up. We're ready to go. What do I have to multiply 3r by to get a 3r to the 5th? Well, that's an r to the 4th. All right, when I actually do that multiplication, I get my 3r to the 5th, and I get a minus r to the 4th. So, to figure out this number here that I'm circling, I ask myself, what do I have to multiply the biggest term in this by to equal the biggest term in this? All right, let me subtract that. 24 minus a negative 1 is 24 plus 1. We get 24r to the 4th. Those canceled. And we can copy down the rest of the polynomial. Now, technically, you only need to copy down one more term. But since I'm only doing this one problem, I want to just do it all the way out officially. Okay, what do I have to multiply 3r by to get a 24r to the 4th? Well, that's going to be an 8r to the 3rd. So that's going to get me my 24r to the 4th. I'm going to multiply it there, but it's also going to get me a minus 8r to the 3rd. All right, I want to subtract that away. And I get plus 30, negative 35 plus 8, because it's minus a negative. That's going to be a negative 27. R to the 3rd. Copy down the rest of it. What do I have to multiply 3r by to get a negative 27r to the 3rd? Well, that's going to be a negative 9r squared, which is going to get me my negative 27r to the 3rd. It's also going to get me my positive 9r squared. Subtract that away. And those cancel. This gets me a negative 6r squared. Copy down the rest of it. And what do I have to multiply negative 3, no, positive 3r by to get a negative 6r squared? Well, that is a negative 2r. So that gets me my negative 6r squared. Gives me a positive 2r. Subtract that away. What are we left with? Those cancel. That becomes a negative 9r plus 3. What do I have to multiply by? I need to multiply by a negative 3. After I multiply by negative 3, I will get my negative 9r plus 3 back. I subtract that away. I get a remainder of 0. Maybe I'll write that in purple to keep with my color scheme. That's my remainder. What I multiplied by was a negative 3, so this is my answer here. So let's just see. 1, 8, negative 9, negative 2, negative 3. 1, 8, negative 9, negative 2, negative 3. Yep, we got it right. All right, so I'll end that here. Good luck studying. Have a good rest of your day.